Okay, now after this, let's go and use the get dummies. So this is nothing but the encoding part, guys. This is nothing but the encoding part. And why I am using it? Yes, I told you axis equal to 1 means I just wanted to drop the columns. If you go ahead with the axis equal to 0, which means that this is for rows. Axis equal to 0 means for rows, axis equal to 1 means for columns. So that's why I used axis equal to 1. So see here I mentioned the labels, not the columns. So for that, okay, I'll have to mention whether I'll have to go for the rows or the columns. So this is the label, okay, not the column and rows. If I mention the column, then I don't need to mention the axis over here, but there is no the attribute for selecting the column name or the row name. So that's why I'll be using the labels and I'll be selecting the axis equal to 1 or 0. So that will define whether I have to go with the doing the operations. This is my operation I'm doing on my data, okay, whether this operation, okay, we can do column wise or row wise. That is the thing. Now understand this. After this, I'll be applying encoding on my categorical data. How many categorical data is there? Three columns which are categorical data: fuel type, sailor type, transmission, isn't it? Okay, now here if you see, if you go over here, okay, in the encoding the categorical variable, so here you will find that, okay, this all the three columns I just took it over here: fuel type, sailor type, and transmission, right? And what I am saying, I'll be using the encoding. Like, if you don't know what encoding is, so let me show you the how the encoding works. So for that I just need to show you in the whiteboard. So give me a minute, I'll be opening the whiteboard so I can show you that. Just give me a minute so I can show you in the whiteboard, so it will be very easy to understand then. Okay, now what about the get dummies? What about get you know dummies? I guess if you see over here, okay, this is not get dummies. If you see, so here if you go over here and let's say this is my data, okay, for understanding, just try to understand this stuff. This is my gender column, guys. In my gender column, how many unique values will be there in my gender column? Gender column, mainly two values, right? Male and female, right? Absolutely. Now here you can see, let's say this is my gender column. Why I took this particular example? Because you will understand this thing. Okay, here you can see that I here drop first equal to true. Okay, that's why I am just trying to show you this thing. Okay, so I can be able to explain you that particular parameter as well, drop first. So now here you can see that, let's say this is my male, female, okay, male, male, female, male, female, female, right? Now here you can see that I just apply the get dummies. So I can simply say gender dummies column, let's say dummies column is this. Now after this, in this particular column, how will be the value? What will be the value in the form of 0 and 1? If you see 0 0 1 0 0 0, now basically get dummies create the dummy column based on your you know the labels, how many labels are there. So let's say this particular column is for the, you can say that the male, right? This column is for the male, M label. So that's why wherever it is M, you will find that the 0 value, right? Wherever it is female, you will find that the exactly opposite value 1, right? Because Python will the computer will understand these two values 0 and 1. So mostly here you will find that the when you go with the get dummies, you will see the values like 0 and 1. If there are more than, you know, the two label, then you will find that the value 0 1 2 3 like this. Okay, and you will see the second column as this gender dummies female. Okay, and here again you can see now this is about the female now. So wherever female is this, you will find the 0 value. Okay, you will find the 0 value. So male, sorry, no, not the male. Yes, my bad. Okay, like as we know, if there is a, you know, female, then 0, otherwise 1. So male na, then 1, then 0 and 0. Now here you can see that we first created the gate dummies. Here just understand, we just, you know, creating the gate dummies. Now how many columns will be created? Let's say this is my gender column, I just wanted to create the dummy. Two columns will be created, okay, initially. Now here what I am saying, drop first or drop last. Okay, both are same. If I go and drop these, let's say I am dropping these, okay, which means that I am just taking this particular column. Okay, and this will saying that 1 0 1 0 1 0 1 0. So that is the thing over here. See, that is the thing over here. Okay, so basically we only took the one column, we removed the one column, because total we have how many columns, how many labels, two na, but we want only one. So let's say if we have the three column, sorry, three labels, male female, let's say any other is there, and let's say we have the what I can say, I have the, let's say the type, unique type. Let me show you this unique type. Let's say I have the fuel type is there. See, in the fuel type I have the three labels: petrol, diesel and CNG. Right, now in that case I'll get the three different columns. Right, I'll get the three different column. See, and now I'll be taking only two columns. Why? Because let's say if, okay, this particular column, okay, if the car is the petrol car, then here you can see the one, otherwise 0 in this particular column. Okay, in the dummy column of the petrol car, right? If there is a car, in the second dummy column you will find that if there is a car and the fuel of type of that particular car is diesel, at that time you will find the one in that particular column, otherwise 0. Now in the third column, if there is a CNG car, then you will find that the fuel type for this CNG car is 1 for this particular column, otherwise 0. So which means that, let's say if there is a CNG car, you know, fuel type is CNG, and so for this here 1. So if, let's say if I drop this CNG car type, okay, that particular dummy column, which means that, okay, whenever the CNG car is there, so at that time you will find that the 0 0 value for both the column. Yes, if the value for the both the column, my petrol dummy column, diesel dummy column is 0, right, and you will find that the, you know, the CNG column is 1. Okay, which means that for this, okay, for getting the fuel type is CNG, okay, we'll have to add the 0 for these two columns. So instead of taking the three column, we can simply go ahead with the two column. That's why here we just added the one term, which is nothing but the drop first, right? Drop first column in simple word, right? So here, that's why we just added this particular type, you know, the parameter you can say. Okay, understood guys, this particular topic? Okay, so that's why we can simply go ahead then. Okay, so what I can do, I can simply run this. So then you will understand this thing. Okay, then you will understand this thing. Now, what I can do, okay, these columns are nothing but my, you can see that the only three columns, viewer time, seller type and transmission. Only three columns we just changed, huh? And after that we just drop this. After adding this column, fuel type, okay, here you can see that we just drop this column from here, from my original data set, in place equal to true. So here in my, okay, here you can see that the number of years old. Okay, now till these, here you can see selling price, cyclic, no, it's not cyclic, I can say. It's like just the drop the one label, any one label. So that's why we are just, instead of dropping any other label, simply drop the first label, right? So here you can see that, okay, after these many column, because these columns are the, numeric column, selling price, present price, kilometer driven, fuel time, not this, owner and number of years old. So here you can see that these five columns are here. Okay, selling price, present price, kilometer driven, owner and number of years. See, and now these columns, these three column you will see over here. Okay, you will see over here. Okay, so basically if you go ahead and see this fuel type, as we know there, okay, like there are three different fuel types, right? There are three different fuel types, right? So that's why here you can see the fuel type only two, petrol or diesel. Okay, because we just drop the first, which means we drop the one label, we drop the one label. If you see, okay, let's go over here. Okay, see, we just drop the one label, CNG. And now what about others? So here you can see that in my sailor type, okay, we have only two columns, so that's why you will see that only one column for the sailor type. What about other transmission? Here again we have the two types, manual and automatic. That's why for those, okay, for these two column you will find that the only one column, sailor type individual and sailor, transmission manual. So if the, sailor type individual zero means the car is automatic, right? And transmission, transmission equal to manual, which means here the one. Otherwise if transmission is, the automatic, then you will find the zero in that particular column. So which means we just transform my data from this particular labels, manual or automatic, dealer or individuals, petrol, diesel or CNG, into the 010101. Okay, now my model will able to understand this thing. Okay, because if I simply put this data, my model will never understand things what it is, because as we know, computer just understand the numbers. Computers just understand the numbers. That's why. Okay, so now here you can see that the number of columns. So just column names here you can see. Okay, if you wanted to see the correlation, because this is about the regression na car price prediction. So price is the numerical value. Yes or no? Price is numerical value. That's why here you can see that data set correlation is there. So you will find that the correlation value. Okay, like as we understood the correlation, what is correlation in the previous session. So again, I'll never go into the depth of the correlation. This is the correlation, and from the here you will be able to understand, is there any relationship between the my, my target selling price, this is my the target column na, and any other remaining column. Okay, that's what we wanted to find out over here. Now after this, here you can see the visualization, data visualization in the heat map. If you see what is heat map, this is the color combination code, guys. If you change it, this is just the code. Okay, this is just the color combination code to get the color combination like this. This is annotate equal to true, which means you will see that the one line for the annotation, right? So that's how we can create the color, data visualization. So what we did, we can simply go for the data dot correlation that we did over here. See, the data dot correlation, we just assign as a correlation matrix. So this is my correlation matrix, if you see, right? Then after that, here you can see that what we are saying, that top correlation features, okay, as the correlation matrix dot index, right? Then what I can do, I can simply go ahead with the plotting the figure, and my figure size will be 10 by 10, 10 centimeter by 10 centimeter. So here you can see that the, the five, squares are, five rectangles are there. So this is about the, each rectangle is for the, you will find that the width is going to be the 2 centimeters for this. And if you go over here and if you see the width, always again the, you can see that the 10 by 10, right? So this is 10 by 10 for the plot, so that's why you will see that the rectangle. So otherwise, because I added this one annotation over here now, so that's why here you can see that the rectangle, otherwise you will see that the squares, because this each thing is the 2 by 2, okay, 2 cross 2. So here you can see that if you go and measure this from here, so you will see that the 10 centimeters. Now if you go the below, I'll be creating the heat map. Okay, what I'm saying, I'll be creating the heat map, and in that I just added my data, which is nothing but my correlation, right? I'm just added my data, which is nothing but the correlation, if you see. And I'm just saying that annotate equal to to see this, and color mapping is there. So this is the color combination code is there. If I make any changes in that, you will see the error. Okay, so I don't want to make any changes in that, because you can use any code over here. You can simply search for the cmap color map code. You will get the lot of color map code. You can use those code over there, over here, right? Instead of this, you will get the another color. Okay, but for now, okay, this is my the color combination depends on the value. You will say that if the value is 0.88, you will see that the color is very dark. If you see these diagonal values are 1, because the correlation between year by itself is always 1. Correlation between x by itself is 1. Okay, because if you see that if I wanted to find out the correlation of myself, it will be 1. Okay, because okay, there is a relationship between me and myself is always 1, because you can see that the me and myself is same. So that's why you can say that the one correlation is that. Okay, and for non-diagonals value, you can see the very less correlation. Okay, just for the one, you can see that the present price. So present price is highly correlated, because this is again, you can say that the very important features for this particular my no the my particular data, you can see. Now let me go and increase the size of the Jupyter notebook, and let me go and explain this further. The plot, this is again very much easy, again, because here we did nothing except for this particular line. Okay, why we use this here instead of using the matplotlib? What we use, we just use the cbon as SNS. If you go over there on the first line, first cell of the code, where we import the library, so here, okay, over there we just imported the cbon library as SNS. Import cbon as SNS, the last library we just imported. So that's what we used over here, right? Now after this, guys, let us go over here and go ahead with the selling price. Just drop it, because here you can see that this is my y data. If you see, this is my y data. Let me go and show you over here. So here you can see what we did. We just drop it from here, okay, and arrange it in the last, because if you see that this is my the target, so it will be very easy to split my data into my input data, which means that my input data, with the help of these columns, I'll be creating the model which can predict the selling price now. So that's what we did over here. Okay, we just transform the order, the index of my selling price, and now we are just splitting my data into my input and output data. So now from here you will be able to see that now we are just building the model. Okay, now after this, guys, okay, after splitting my data into x and y, there is one more thing. I just wanted to check the features. What I wanted to check is features importance. Okay, like which features having how much importance in my analysis. So what I can do, I can simply use a sklearn.ensemble, and we are using this particular algorithm, extra trees algorithm. There are a lot of algorithm, as I told you. Okay, as we understood the decision tree, random forest, logistic regression in the previous session, in the same way you will find that the extra tree regressive algorithm is there. This is again the tree based algorithm you will find. We are creating this and we are fitting it. Why we are doing this? Not to build the model. We are doing this not to build the model. We are doing this to understand the feature importance. Okay, you can use the random forest as well. Random forest is again find you the feature importance, okay, of your each and every feature. You can go with that as well. Okay, you can go with that XGBoost regressor as well, right? There are so many multiple algorithms. You can go with that to find out the feature importance, but for now we will be using the extra trees regressor. Let's go and run this. Okay, now we here you can see rest of the things are just the plot. We just use the, you know, the PD to get the series, to get the feature importance. Okay, to get this particular series, the vector you can say. Okay, and here we just use the matplotlib library to show the feature. Okay, and which kind of plot we are creating? We are creating the bar plot, bar h, which means bar plot is there, right? And here you can see that we just put it this into the largest, which means the, you know, ascending order. So you can see the ascending order like this. So first is nothing but the owner is nothing but the less importance having. The highest importance, okay, is related to the present price, which you can see over here in the, you know, in the 0.88 correlation with the, which, with the, you can say that the selling price. If you see that the selling price and the present price correlation, okay, now let me show you over here. Okay, if you see that, see, this is my present price column and this is my selling price. If you see the third column, the third row, present price, if you see over here, my second column is selling price. Okay, either go or you know, lower triangle matrix or the upper triangle, both the way you can see 0.88 0.88 for selling price and the present price. Okay, which means that there is a very strong relationship between the selling price and present price. If your car is, you know, if your, you know, the market price, you can say that the your showroom price of your car is, let's say, 1 crore, right? And after a few years you are, you know, selling that particular car, then you will get the, you know, money like this. You will get the amount which is, you know, which is like that particular amount. Okay, either 50 lakhs 40 lakhs like that. If you purchased this car from the showroom as a, let's say, 30, in the 30 lakhs, then when you go to sell that particular car, you will get the amount like this now. So that is why, okay, you will see that the present price is the highest importance, okay, in the particular data. Okay, in the particular analysis you can see. Then the, then after that, fuel type. Okay, fuel type is the feature. You will see that again the second highest important variable or the feature. Then the third one, transmission, manual or automatic. Nowadays it is very important factor. Okay, while we like, if you wanted to purchase, we can just go and see the car is automatic features or not, car is having automatic features or not. So like the, you know, different automatic features you can see. So again the transmission is, you can see that the third most important feature. Then the seller type, if it is individual or the dealer. You know, many of us are just preferring the individual, not from the dealer, because dealers are just, you know, taking the commission. So like it's something like the, you know, increase in the price of the car. So that's why here you can see that the, again the fourth most feature. So like that you can see the, you know, the feature importance plot. I just plotted for you guys to understand this, you know, these different things, like how the machine learning can understand this. Like see, like if you wanted to, you know, just purchase the price, purchase the car, then at that time you can also go with the same procedure. You can, you can see the price, showroom price of that particular car. You will always see the fuel type, whether the petrol and diesel, isn't it? Okay, like how we are just managing thing, how we are just going with the question and answering kind of, you know, thing like this. The machine learning also doing the same thing. That is why in the name itself you will see that the machine learning is there, you know. Now let us go ahead with the next, guys. Let me increase the font size. Now here you can see we are just building the model. For that, as we know, we are just splitting my data into X and Y. Let's split my data into X and Y. And these are the few evaluation matrices like the cross validation score. Let me explain this after, just, getting the value for each and every score. So after this, here you can see we are splitting my data into train and test. As I told you, we are just splitting our data into train and test, you know. So how many, in how much order we are, just a ratio of the train and test will be like 70-30. Okay, 70% of my data will be in a train and 30% of my data will be in a test, right? So this is the thing. Let's go and run this. Now after this, guys, okay, we will be talking about the decision tree regressor. Now after splitting my data into the train and test, let's go and build the model. So as we understood that, guys, okay, how many models we created previously? We saw the regression model, logistic regression, decision tree, random forest. Okay, so now here we are just using the decision tree and random forest to build the model. So here you can see my decision tree regressor is here. Okay, here you can see we just imported my decision tree regressor. We just, build the model, which is my empty model, and now we are fitting my model on my train data, X and Y train data, if you see. And what we are doing, we are making the prediction in the fourth line of code. Now after that, this is my just the 4 line of code. Okay, you can make it in 1 line as well if you want. You can put the fit over here, dot fit, and after that you can fit, user dot predict after the dot fit. You can put it into the 1 line, so you can build the model and make the prediction in 1 line as well. Okay, like I'll show you all these thing like in a very detailed manner in the course. Like if you go ahead with that course now, so I'll show you that again in that course. Okay, so here you can see that next thing is that what I'm doing, I'm just making the print of my accuracy. Okay, this is score dot score is nothing but the accuracy, and the accuracy is what? Training accuracy, because here you can see that we just added the train data na, so that's why training accuracy we are just finding out. Second thing is that I just wanted to find out the test accuracy. As we know, okay, we are just evaluating the model based on my test accuracy. So here you can see this is my test accuracy. Third thing is that cross validation. Okay, the cross validation is a technique of the sampling. As I told you, the one sampling method, the not one, few sampling method, random sampling, then stratified sampling, systematic sampling, cluster sampling, like that I told you few. So this is nothing but the cross validation sampling as well. So in that particular thing, model just, while before creating the model, okay, we are just splitting my data into the, the how many parts. Here you can see cross validation equal to 5. So basically in 5 parts I just splitted my data in the first. Now what I can do, I can took the first 4 part as my train, and I took the last part as my validation. Okay, that's why cross validation you can see. Now in the second thing, now after this I can find out the accuracy, and I go for the second. So here you will find that the 5 different accuracies with this cross validation. So you can understand, okay, which split you want, either the first fourth and one, or the first three, which means that first three and the fifth one into the training and the fourth one into the testing, like that. Okay, so that's how we can go ahead with and find out this. This is a bit advanced part, guys. Then print the accuracies for the cross validation. You will see that the 5 accuracies for that. Then after this, here you can see that we are just finding out these accuracies will be in the, points. Okay, 0.89, 0.9, like this. So here we are just transforming it into the percentage. Okay, like this, 90, 80, 89, like this. Okay, we are doing the same with the standard deviation, right? Accuracy, standard deviation. Now after this, as I told you, this particular evaluation matrices, mean absolute error, mean square error, so these are nothing but the, the errors of my model. So that's what we are doing over here, right? And again this, again the one more thing, root mean square error, right? Again these three things are nothing but the errors. These are the three different types, so you can find out the errors. Like I told you, I mentioned this in my course curriculum na, so that's why I mentioned this over here in the data science project. After this, here you can see that the r square, r square is nothing but the evaluation matrix of the regression. So this is our regression problem, car price prediction. That's why I added over the this. Now after this, guys, here you can see that we are just creating the distribution plot. Okay, now here each and every time my Python is updating, that's why here, okay, we might get the warnings, but just we are ignoring the warning. And here you can see that we are just creating the scatter plot. Now let's go and run this. So see, I got the warning. Okay, what kind of warning I got? It is saying that use the dist plot or the use the hist plot, okay, instead of the distribution plot. I use the dist plot now. Now what they did is, okay, what developer did, they just remove the t from here, and now they are saying use the dist plot. This is their update. Okay, so I don't want this update, because you can see that they just remove the t from here, and now they are saying that use the dist plot. Now I don't want to make any changes in my code, so that's why I'll go with this same, right? So that's why I'm ignoring this particular warning, right? User warning is this. Okay, now let me explain this particular code with you. This plot is nothing but the distribution plot. See, okay, like I told you, the distribution plot. So in the dist plot, okay, you will see that the same, okay, but you will see only the bars. You will see, let me show you. Okay, let me just go over here, let me just remove the t from here. Now first you can see the how the distribution plot looks like, dist plot. Okay, now we can go with the dist plot. Let me go and run this again. Now here you can see warning is gone, and now we got the plot. But now it's bit difficult to understand this. There is no curve, there is no line of curve is there, right, to understand whether my plot is normal or not na. So that's why I go with the t. Okay, and here I want the warning, no issue. Okay, but here you can see that now I am able to understand this plot in a very good manner, because here you can see that the line of curve. So I can say that yes, my how my density distribution of my data looks like, right? This is the thing. Now here you can see that the training accuracy 100% for the decision tree. Then the training accuracy for the test. So for test data, my training at testing accuracy is going to be the 92%. Okay, but here you can see I'm comfortable to see these plots with the help of this plot na. So I'm just ignoring this warning and I'm going with the same plot, right? That is the thing here. Now here, as I told you, the CV cross validation score, CV equal to 5. That's why here I got the 5 accuracies. See, this is my 5 accuracy, and this is the average of my 5 accuracies, 86%, right? Then the standard deviation is 9.22%. Why? Because here you can see in the first you will find that the 95 accuracy, 84, then 69 only directly, then 92. That's why here you can see that the standard deviation is 9.22. Then these are the error. Okay, error are nothing but the what are the errors in your model. Okay, and these are the few evaluation matrices you can go ahead with. So these are just the understand the things. Okay, understand your model based on the error. You can compare it the error with the multiple models, like we are comparing it with the another model, which is our random forest model. Then these three are nothing but the error. The r square is 92%. Again, the very good r square, I can say. Okay, so what I can do, I can simply go ahead with the random forest regression now. Now, as I know, as I told you this all, so I can simply go with, okay, and I can simply run this because the code is same. The code is same. There is no different. I just imported it. I just created it. I just fit it on my train data. I make the prediction on the test data, and I can find out the accuracy, training, testing, and all these things. So the here you can see the training accuracy, here you can see the testing accuracy. Testing accuracy will be 86%, and for this, here you can see the 92% training testing accuracy. Okay, so here you can see that the decision tree model is good than the random forest. Okay, now after this, here you can see all the things CV accuracy is there, and now you can compare the errors with the previous model. Okay, whichever model give you the lowest value, go with that particular model, go with that particular model. Now the third thing is that, okay, so this is the thing. Now after this, here you can see we have the voting regressor. This is some kind of regression. You can use the multiple model in it, and you can go with the voting regressor simply. Okay, see here, I'm just using my decision tree, again the random forest, and I'm using it. Okay, I'm importing it from the ensemble method, which is same we imported the random forest is, right? And I'm doing the same thing. See, the code is same for all the three model. Okay, because just for the simplification, okay, just to understand the code, you will understand the code, that's why I did this. Okay, let's go and run this. Okay, now after this, here you can see all the things. Okay, here the, you know, the voting accuracy is going to be the 90%. Okay, here there is some, you know, problem with the decision tree, because the decision tree might give you the overfitted results. So here you can see that the training accuracy is 100%, which means that the model is overfitted. Okay, the accuracy is good 92%, but here the model is overfitting model. Okay, and no one accept the overfitted model, so that's why I'll have to go with the another model. That's why I did this. Okay, and I got the accuracy as the 90%, and my model is now around 98% accurate. Okay, so again you can see that the, you know, the quality for this model is good as compared to the decision tree or random forest. So what I can do, I can simply go over here and I can select this model and I can save it into the pickle file. Okay, I can simply dump my, you know, model into the pickle file. Okay, and I can simply load, and I can show you how my model works. You know, I'll just add the values, random values I just added as my, the, you know, my, you know, you can say present price. Here you can see the petrol, you know, how long this car driven like this. So I did this all, and I just got the output. Okay, now I want this kind of output in my, you know, app, in my app. Now after building it, you know, let's move to this, and here you can see a few templates. Okay, this template is basically the template of your web page. So here, few, you know, few line of HTML you will have to know. Okay, like this is not the big thing. Okay, in 1 hour you will understand the HTML. Okay, this is not the big thing, you will understand this into the 1 hour. Okay, this is the CSS, this is the, you know, the, we can say that the designing part of the HTML. Okay, this is the CSS and HTML we did. Now what we can do, we can simply, after showing you this pickle file, I can simply open the Anaconda prompt. Anaconda prompt, I can simply open it. Okay, let me open this. Okay, now what I can do, now see, those who wanted to see how I can created that particular plot now, that particular web page. So for those, here you can see, just go and select the folder which you have the app.py file. This is my app.py file, this is my path. Copy this path, and in the Anaconda prompt, use it. Okay, first mention the cd, which means change the directory, and simply paste this path over here, enter this, and now simply use this code as the, simply use this code as the python app.py and enter it. That's it. Okay, that's it guys, and now here you can go. It will take some time to process, and now it will give you the one, you know, the one, you can say HTTP. output. So simply use the control, okay, and enter this. And now here you can see, simply select this, and now this particular link automatically, okay, get over here in the, you know, the browser. You can see now you can simply the add, and you can get the predictions from here. Now let me go with the 2011 11 lakh, then the 12,000 kilometer driven car, okay, previous owner, the second hand car is this, okay. I just, let's go with the CNG now, okay, and then the dealer or individual, let's say the dealer now, okay, the manual car or automatic car now. Okay, selling price will be 7,44,000. Okay, that is how you can go ahead with. Okay,